Assalamualaikum and salam sejahtera student. We are now entering chapter 3, which is vectors. Vectors is one of the important topics in mathematics which is involved a lot in our daily routine. You may not realize about it, but you have been using vectors and applied vectors in your daily routine. I believe that you are used to be asked a direction from point A to point B. Or you yourself ask people a direction from point A to point B, don't you? If you say yes, then that is one of the example of vector in our daily routine. Other example is a speeding car on a highway. When a car speed with 100 km per second toward south, that is one of the example of vector as well. Okay, so it can be concluded here, a vector is a mathematical quantity that has both magnitude and direction. So the important keyword here is vector must come with magnitude and direction. If you tell the people just giving the information about the direction, okay, whether to the left, to the right, north, south, east, west, that is just a direction, okay, it is not a vector. Same goes if you just tell people about the magnitude. For example, oh, to go from point A to point B, it's just 10 kilometers. This is not a vector as well, okay, because a vector must include magnitude and direction, okay. So if you say from point A to point B, you walk 10 meters to the left, then you will reach point B. Yes, this is a vector. So you have the direction here. Sorry, this is the right direction. And you have the magnitude here, which is 10 meters. Okay. So other example of vector are displacement, velocity, acceleration, force, and so many. Okay. Direction with a magnitude is called vector. Direction alone is meaningless. If you just use a direction, it is meaningless. If you use magnitude alone, this is called scalar. Okay, so combination of direction and magnitude, that is vector. Okay, direction alone, it is meaningless. You won't go anywhere with just telling people a direction. Okay, but magnitude alone is called scalar. Okay, at least you have the idea how far you go. You can go to reach B, point B. Okay, but still it is not very helpful without a direction. Understand? Right? So example of magnitude, which we call scalar, is temperature, mass, length, and area. These are all examples of mathematical quantity that do not need a direction. Okay, so to tell the temperature of your body, you don't need a direction, you just need a scalar, okay, which is the magnitude, how much, 35 degree. For example, your weight, you don't need direction for your weight, okay, so your weight is a scalar, okay, 45 kilogram is my weight, for example, okay, so that is a scalar. Same goes to length and the area, okay, so you don't need direction for length and the area, okay. So for temperature, mass, length, area, these are all not vector, okay, but they are scalar, okay, they are quantified by a quantity, okay. We denote a vector by using an arrow, okay, so we use arrow to denote vector, right, and vector always start from one point to the another point, okay, so the first point is called initial point and the second point is called the terminal point. So you can denote initial point as point A and terminal point as point B. So from point A to point B, where we write it as from A to point B with an arrow on top of it, this is a symbol or notation that is used for vector. Okay, or some books will use small letter A with the underline under the letter A, small letter A. This is also a notation used for vector. Okay, and the length or the magnitude from point A to point B, we write it as in between the two straight lines like this. Okay, so this is the length or the magnitude of from point A to point B. Okay, we connect point A to point B by using a straight line with an arrow like this. Okay, so we know here that by using the arrow like this, okay, it means here the starting point, the initial point is from point A, so point A to point B, and B will be your terminal point. Okay, let's say if you have two vectors, which is vector A and vector B. So here the notation that we use is small letter A with underline beneath it and small letter B with underline beneath it to represent the first vector here and the second vector. Okay, so this is the first vector, this is the second vector. Alright, or if you don't want to write small letter A with underline beneath it, you can denote this as point A1 and the terminal point here as A2. Why this is terminal? This is the terminal point because the arrow is towards there. Okay, so it means it starts or the initial point is A1 to A2. Okay, so you can use A1, A2 with the arrow on top of them. Okay, same goes to B. If you don't want to use B, small letter B with underline, okay, you can label this as B1 goes toward B2. Okay, capital B1, capital B2 with the arrow on top of them. Alright, so no matter how, okay, which one you use, it doesn't matter because they are similar. Right, so in this case, if you have two vectors, you can declare that these two vectors are equal. Okay, they are equal if only if they have same direction and same magnitude. Okay, so same magnitude, same direction. If both of the vectors has equal magnitude and equal direction, then they are said to be equal. Okay, so if one of the vectors has different magnitude or different direction, then you cannot say that they are equal. Okay, even though they have equal magnitude, but with different direction, they are not equal. Okay, if they have same direction but different magnitude, they are also not equal. Right? A and B are equal if and only if they have same magnitude, same direction. Understood? Okay, please listen carefully to my explanation. Alright, so if you just have one dot like this, that is called A, this is called a point. This is called point. So it's static. It just here, static. This is called point. If you have another point, this is point B, which is also static. So this is point B. Okay. When you connect point A to point B, this is called vector. Vector AB, or denoted as A underline beneath it. Okay, understand? If you just have one dot, this is just a point. Okay, and you have the second dot here, you denote as B. This is also a point, right? But when you connect these 2 points with a straight line here, and you put an arrow to the line, this is called vector AB, or we denote it as small letter A with underline beneath it. Okay, so for a vector, okay, it can has a component form. Alright, so for on a plane, okay, on a plane, minimum component is 2. That is for 2D plane. Okay, for 2D plane, which is consists of x-axis and y-axis, this is 2D plane. Okay, if you have a vector here, this vector, okay, this vector, the component is x and y. Alright, so for a vector, let's say A, this is a vector. We can write the component for vector A as x and y. This is for 2D plane. Right? But for 3D vector, which consists of x-axis, y-axis, and z-axis. Okay, remember this is 3D. Okay, so if you have point O here, this is the origin, 2 point V here, okay, or we denote it as V underlined, right? This vector, the component is V1, V2, V3, where V1 is component X, V2 is component Y, and V3 is component Z. Okay, so it depends to the vector. If it is 2D, then it will have 2 components. If your vector is 3D, then it will have 3 components. Understand? Okay, I didn't mention just now, okay, about how to write a point and what is the difference with a point and a vector, a component, okay? So if you have point A, for example, okay, you write point A as the component of point A in a bracket. Okay, so a bracket just used for point. But for a component of vector A, we use this bracket. Okay, the arrow bracket. This is for vector component. Okay, so please be careful in this topic. When you see a bracket, okay, this is for a point. If you look at this bracket, arrow bracket, this is for vector component. Then you know this is not just a point, this is a vector component for vector A to vector B, for example. Okay, or we denote as this. Alright, so the next definition is magnitude or the length. Okay, so remember magnitude is length. So the magnitude of vector V or vector P to vector Q, we can calculate by using this formula. Okay, it is just the square root of the summation of the square for each component. Okay, or if you use a point, it is similar to x2 minus x1 square plus y2 minus y1 square plus z2 minus z1 square. Okay, so there is a difference between this formula and this formula. Okay, so let's say you have a 3D component, 3D vector, sorry. Okay, this is point P. And point P is from the component for point P is x, y, z. Okay, x1, y1, z1. And you have the second point, which is Q here, and the component is x2, y2, z2. Right? P is a point with a component x1, y1, z1. And Q is a point with x2, y2, z2. Okay? When we connect P with Q, you will form vector PQ. Okay, so I connect these 2 points. You form a vector PQ, or simply write it as V underline. Right? And PQ is equal to x2 minus x1 y1 y2 minus y1 z2 minus z1. Okay, so the component for vector PQ is equal to x2 minus with x1. Then you get the length for PQ. Okay, so this is for V1. And when you minus y2 with y1, you get the second component, which is V2. When you minus z2 with z1, you get the third component for V, or vector PQ. Okay, so actually they are similar, but it's just been writing in a different form. One is written in a vector component, and this one is written in point. Okay, but eventually when you subtract x1, x2 minus x1, you get a component for vector PQ, the first component of vector PQ. And the next subtraction will give you the second component for vector PQ, and last component z2 minus z1 will give you the third component for PQ. Okay, so whichever you use, they should give you the similar answer. Alright, so student always confused when to use this and this. Alright, so in the in this topic, if you were given a vector component, then you apply this one. If you were given a point, okay, if you were given points, okay, 2 points, then use this one to calculate for the magnitude. Let us look at the first example here, okay, on how to find the component form and the magnitude for vector PQ. Okay, now you were given 2 points, which is point P and point Q. So it is obvious here that you have 2 points. Okay, so let's say this is point P with component minus 3, 4, 1. So P here is the initial point. So it is mentioned here that this is initial point. And you have the second point, which is point Q with the with the component minus 5, 2, 2. Okay, and this is your terminal point. So when this is your inertia, means it will start here, goes toward Q here. Connect them with a straight line and the arrow here. Then here you go, you have vector PQ. Okay, so what is the component for vector PQ here? The component for vector PQ here is, take the terminal point minus with the initial point. Okay, so here component for PQ is, so take the first minus 5 minus with minus 3, that is plus 3. The second component is 2 minus with 4, and the third one is 2 minus with 1. That will give you minus 2. 2 minus 4 is minus 2. 2 minus 1 is 1. Alright, so this is the component form of PQ. Alright, so check. Correct. Okay, now to find the length, okay, since you have calculated, you have found the component for PQ, so you just directly apply this. So just apply the formula to find for PQ. Okay, magnitude. Okay, the length. This is the length. Magnitude, which is equal to. This is equivalent to V1, V2, V3. This is just your notation. It can be X1, X2, X3, or Y1, Y2, Y3, or any. As long as, because this is 3D, so it must have 3 components. Alright, so you can just directly apply this. Minus 2 squared. Plus the second component is minus 2 squared. Plus the third component is 1 squared. Okay, so you have 4 plus 4 plus 1, that is square root of 9, that is equivalent to 3. So this is the magnitude for vector PQ. Okay, if you want to use the point, it is also fine. So you can use this one. Okay, so it is square root of minus 5 plus 3, don't forget to square, plus 2 minus 4, don't forget to square, plus 2 minus 1, don't forget to square. You should get the similar answer, which is eventually comes to this. Right? So this is minus 2 squared plus minus 2 squared plus 1 squared. So equal to 3. Okay, so now hopefully you see the difference. It is not actually a difference, just a different way of calculating the length. Okay, one by using the points and the other one by using the component. Similar to other mathematical quantities, vector also can be added, can be multiplied, and can be subtracted. Okay, subtracted. Alright, if you have two vectors, okay, for example, vector u and vector v, okay, which is 3D and 3D component, okay, you can add vector u with vector v with a condition that the first component is added to the first component. Okay, second component is added to the second component, and the third component is added to the third component. So you must make sure that the addition of two vectors is still a vector. Okay, so you should remain the form, the component form of the vector. So you must have 3 components. Okay, so the component must, the first component, second component, and the third component must be added to its respective component. Okay, so you cannot mix with you cannot add u1 with v2 or u2 with v3. Okay, that is not how it works. The first component must be added to the first component, the second must be added to the second component, the third must be added to the third component, so that we remain the component form of the vector. Alright, so must make sure that you add two vectors, the summation must be a vector. Okay, must still be a vector. Okay, and then you can multiply a scalar to a vector, which means if you multiply scalar k to vector u here, okay, you must multiply each component by k. Okay, so you multiply k to vector u, right? So each of the component of vector u must multiply by k. So the first component multiplied with k, the second component multiplied with k, the third component also multiply with k. Okay, for example, let k be equal to 2 and you have vector u which is 2, 1, minus 1. So if k times the vector u, it means that you multiply 2 with vector 2, 1, minus 1. Okay, which will produce new component which is 4. 2 times 2 is 4. The second component 2 times 1 is 2. The third component is 2 times minus 1 is minus 2. Okay, so this is 2u. Understand? While for this one, for addition, if you have u equal to 2, 1, minus 1, v, vector v equal to 5, 0, 3, then u, vector u plus vector v is equivalent to the first component plus with the first component, which is 2 plus 5 is 7. And the second component is 1 plus 0 is 1. The third component is minus 1 plus 3 is 2. Okay, so this is your vector u plus vector v. The resultant vector from the addition of vectors of two vectors, okay, can be produced by using two laws. The first law is the triangle law, and the second law is the parallelogram law. Okay, now let us look at the first law. We can draw a line or a vector for the resultant vector u plus vector v, okay, by connecting the initial point of u with the terminal point of v. So this is a correct. There is a correction here. Okay, this is the terminal of point v. Okay, so let me start from the beginning. Okay, so let's see if you have two vectors. This is the first vector. Okay, let this to be u. And you have the second vector v. Okay, so now I want to add vector u with vector v. Okay, we know that each vector has the initial point. Okay, this is the initial point and the terminal point. Same goes to v here. It has the starting point, the initial point, and it has the terminal point. Alright, so when we do addition to vector u and vector v, okay, and we want to look at we want to draw the resulting vector of this addition, what we can do is we can add these two vectors by connecting them with the terminal point of the first vector. Okay, you know this is the first, this is the second vector, right? So you connect the terminal point of the first vector with the initial point of the second vector. So you will form this. Okay, so remain the direction of this. Okay, direction of this. So this is vector u, where this is the initial point. Okay, initial point. This is the terminal point. Okay, this terminal point you connect with the initial point of your V. So the direction will remain there. Okay, so this is the terminal point of vector u, which is also the initial point of vector v. And this is the terminal point of vector v. This is the initial point of vector v. So where is the resulting vector? The resulting vector is this, connecting the initial point of vector u with the terminal point of vector v. So the arrow is there. Okay, so this is the resulting vector u plus vector v. Alright, so make sure, look at the arrow there. We follow there to there, and the resulting vector is this. Okay, so never change the direction. Make sure you don't change the direction. Direction must follow there and there. And the resulting is must start from the initial point of the first vector. Okay, and the arrow goes there. Understand? So where is u plus v? Vector u plus v is here. Right? And if you use this method, this is called the triangle law. Okay, the second law that can be used to find the resulting vector of the addition of two vectors is the parallelogram law. Okay. In parallelogram law, we will connect the two vectors by using their initial points. Okay. So if you have two vector u and vector v, okay, you will connect the initial point of these two vectors. So this point connect with the initial vector of the second vector here. Okay. So what you do is, okay, just start with any of the vector. Okay, so this is u, that is the direction, this is the initial, and this is the terminal, right? And then connect the initial of the first vector here with the initial of the second vector here, which is this. Okay, so start with from here to here. Okay, so this is your second vector v. Okay, remember this is the initial and the direction goes there, same like this. Okay, from initial to the terminal. So this is the terminal. Alright, and then make sure you make another line which is just like a virtual line to represent u. Okay, with the same direction there. And this is a virtual line for vector u. Okay, now you have formed a parallel shape. Alright, and if you want to know the resulting vector of the summation between vector u and vector v here, okay, it is the diagonal of the parallelogram, which is this. Okay, and the arrow will follow from the initial, and this will be the terminal. Okay, so the arrow will be there. This is the resulting vector u plus vector v. Right? This is called the parallelogram law. You use this method, connecting the initial with the initial. Okay, so look at carefully the direction of this vector. Alright, for if you use the first law, okay, which is the triangle law, okay, this is the U, right? Okay, and you connect with the terminal point of U, you connect with the initial point of V. V, U. Okay, and the direction is here. And the resulting is the initial with the terminal point of this. You connect these two. This is U plus V. Okay, so take note, they should be the same. Okay, if U and U here have the same direction, same length, okay, same goes to V. If V here and this V has same length and same direction, then this U plus V should have equal direction and equal length as well. No matter which law you use, whether it is triangle law or the parallelogram law. Alright, so look at the direction of the vector for these two law. Alright, the triangle law create the closed shape. Okay, so you have the closed shape here. Alright, while if you use the second law, you have an open shape here. Okay, it is not very obvious unless you draw the virtual line here. Okay, without this and that, it is just an open shape. Alright, okay, and make sure when you put the arrow, you put the correct direction to your vector. Okay, so if you use triangle law, make sure it is from the initial to the terminal. Okay, from the initial to the terminal. Okay, don't change it to become that way. This is wrong because there is no stop for this direction if you put the arrow this way. You see, it start here, go there, and then it goes here. It can make a round without a stop. Okay, so this is the sign of putting the wrong direction. Okay, so the real one must be going there, follow to there. Okay, you plus these two, and the resulting must be there. Okay, go there. So it go there and go there, then eventually the vector will stop here. Okay, these two goes there, and this one also go there. So this will be the terminal, the end point. While if you put the sign, the arrow to be this way, there is never ending point here because it keeps on, flowing there to there and here. Okay, and then it can go there again and again. Okay,